Try it on your own. Example 15 and 16. These are the last two problems. So pause the video. Do these on your own. You're getting them in the form of y equals mx plus b. Then you're going to examine to see if they have same or different slopes, same or different y-intercepts. Tell me which type of lines they are, either intersecting, parallel, or coinciding, and then tell me how many solutions. One solution, no solution, or infinite. Pause the video and do these on your own. When you're finished, press play, and let's go over it. All right, so for the first one, I want to get y on the left side. Remember, these have to look like y equals mx plus b before we can examine their slopes and stuff. So I'm going to start by moving this y to the other side by adding y. What you do to one side, you do to the other. So now I have y plus 8 on the left, and minus y and plus y cancel out. I'm left with a negative 2x. Now I need to move this plus 8 by doing the opposite, which is minus 8. Plus 8 minus 8 cancel. I'm left with y equals, and now I have my minus 2x minus 8. So that's it in slope-intercept form. Equation 2, I want to get this y by itself, so I'm going to start by moving this 5x by subtracting 5x. Minus 5x and plus 5x cancel out. I'm left with negative 2y. And now I want to write this in the form of negative 5x minus 2, so it looks like mx plus b. Divide by negative 2. We've got to divide each term by negative 2. So negative 5x divided by negative 2 is going to simplify to just a 5 over 2x, because negative negative becomes positive. And then negative 2 divided by negative 2 is a positive 1. So right off the bat, I can automatically tell a couple things about these equations. They already have different slopes. They already have different y-intercepts. So I already know these are going to be intersecting. They're going to be intersecting lines which have one solution wherever they intersect. And I don't know where these lines are going to intersect because they don't intersect on the y-intercept. So we just write intersecting lines, one solution, because they have different slopes and different y-intercepts. Number 16, last one. Hopefully you've tried these as well. So I want to get the y alone. So I'm going to start by subtracting 5x on this first one. Minus 5x and plus 5x cancel. I'm left with 2y, bring it down. On this side, I want to write this in the form of mx plus b, so negative 5x minus 16. Now I'm going to divide by 2 to move that 2 to get y alone. Negative 5/2 x. We're just going to leave that. And negative 16 divided by 2 is a negative 8. This one is ready for examining. All right, and the last one, I have my y here, so I want to start by subtracting 15x. What you do to one side, you do to the other. So the plus 15x and minus 15x cancel. I'm left with 6y. Bring it down. This I'm going to write in the order of mx plus b, so negative 15x plus 6, because that's a positive 6. Divide by 6. Each term gets divided by 6. And that leaves me with y equals negative 15 divided by 6. That doesn't reduce to a whole number, but we can reduce it because 3 goes into both of these. So 3 goes into negative 15, negative 5 times, and 3 goes into 6, 2 times. So negative 5/2 x, and then positive 6 divided by 6 is a positive 1. So now we examine, and the first thing I see is they have the same slope, but they have different y-intercepts, okay? Because this one starts at negative 8, and this one starts at positive 1. So same slope, so the same steepness, but they're going to start at different places on the graph, which means these have to be parallel. P-A-R-A-L-L-E-L, if I could spell it right, parallel lines, which have no solution, because remember, they're the sad love story. They never ever meet. So hopefully you understand now how to determine how many solutions by examining, but you have to have them in slope-intercept form so that you can examine if their slopes are the same or different, and if their y-intercepts are the same or different, to determine if they're parallel lines, intersecting lines, or coinciding. And then you can determine if they're going to have one solution, no solution, or infinite solutions.